All right, welcome to 4.3 quadratic functions and our essential question, how do you model data with quadratic functions? So we're going to start off here. First, last time we graphed it from an equation. Now we have a graph. We're going to write the equation, and we're going to write it in vertex form. And if you remember vertex form, it was the one that looked like absolute value. And so we had a times x minus h squared plus k. Okay, where hk was the vertex, right? So we would move right or left, and then up or down, and then this determined how narrow or how wide it was. So our first step, where's our vertex at? Our vertex point is at, let's see, what is this? -4, and it goes up 2. Okay, so if we were to write our equation so far, we don't know what a is yet. X minus h. Now remember, this is h and this is k. So instead of writing h, we're going to plug in -4 squared and then plus 2. Okay, now if we were to simplify that a little bit, we have a and then x plus 4, right? Because plus means we're going to the left, and we did. We went to the left. Squared plus 2. Okay, now we need to find what a is. We don't have a clue what a is. We know it has to be negative because it goes downwards. And so we're just going to find a point on this line that's nice and easy. A nice easy point right here is 0, -6. And we're going to plug it in for x and for y, and we're going to solve for a. Okay, so we know that y is -6, and then we have a, and then 0 plus 4 squared plus 2. Okay, 0 plus 4 is 4, so we have a times 4 squared plus 2. So then -6 equals 16a plus 2. And now we do a little algebra here. We subtract 2, so we get -8 equals 16a. And when we divide by 16, we get -1/2. Okay, so we did all that work to get our a, which is -1/2. And our last step is to just plug it back up into that equation. And so our final answer here is going to be y equals -1/2, and then x plus 4 squared plus 2. Okay, so we find our vertex point, plug it in, and then to find a, we find another easy point on our graph, plug that in for x and y, and we solve for a and then plug a back in, and we're done. All right, now today we're going to be working with a little bit more real-world problems here. So the arch of the Sydney Harbor Bridge is approximately 500 meters long. Okay, so from here to here is 500 meters and about 85 meters high. So in the y direction, we're up to about 85. We need to figure out a quadratic function that models the curve of the arc, and we're going to assume that the arch, and we're going to assume that it starts at 0, 0, so the point 0, 0 down here. Okay. Now our first step, just like in this problem, is to find the vertex. Now, we know that the vertex lies right about here. We just don't know what that point is, right? And so, in order to find it, we have to realize that isn't it halfway between the two? So if the whole length is 500, the vertex is going to occur halfway between it. And so it's going to occur at 250. And then how high is it when it hits that top point? It's 85. Okay, so we have our vertex point is 250, 85. It's halfway between, and then it's 85 up. All right, so same thing we did before. We plug it in, so y equals, we don't know our a yet, and then x minus h, which happens to be 250 squared, plus k, which is 85. Okay, now we need one more easy point to plug in, and I see that this is an easy point right here. We're at 500, 0. So I'm just going to plug 500 in here, 0 in here. So we end up with 0 equals a times 500 minus 250 squared plus 85. 0 equals a. This would be 250 squared. Okay, so 0 equals, let me grab a calculator here, 250 squared. There's a nice big number. 62,500. A plus 85. Okay, when we subtract it, we get negative 85 equals 62,500 A. When we divide, we get A equals, so we have negative 85 divided by 62,500. Nice little decimal here. So we end up with y. A equals negative 0.00136. Okay, so when we plug in the final equation, negative 0.00136, and then we have the rest of our formula here, right, up here. So x minus 250 squared plus 85. All right, now we're going to head into some vertical motion. And anytime we have vertical motion, so like if a projectile gets shot out of a cannon, or if a ball goes through the air, or whatever, we're going to use this equation. And c is the initial height, v is the velocity, the upward velocity, and t would be time. And then y is going to be the height above the ground. All right, so we're going to apply this equation. I'll rewrite it for us. Negative 16 t squared plus vt plus c. Okay, we're just going to use this equation and plug it in. So we have a basketball game, and from a height of 5 feet, a slingshot launches t-shirts into the crowd. The initial upward velocity is 64 feet per second, and the t-shirt is caught 35 feet above the court. So let's draw a picture of what's happening here. If we had our graph, now it's starting at 5 feet above the ground, and then it gets shot upward into the stands, and then it lands at 35 feet, right? And obviously my graph is just sketch, it's not accurate, but this is kind of what it looks like. It's getting shot up into the crowd and then it stops. Okay, and so how long does it take for the t-shirt to reach its max height? Well, our max height is up at the vertex up here, right? So we need to find the vertex, and in order to do that, we're going to have to find the axis of symmetry and then find the vertex point. Okay. If you look at this, we kind of have an ax squared plus bx plus c look, don't we? And so we can use that negative b over 2a that we learned a couple days ago. So let's plug the equation, let's plug what we know into the equation. So negative 16, it doesn't say anything about time, right? In fact, that's what we're solving for. How long does it take, right? And so t squared. Now we know our initial velocity is 64 feet per second. Let me get rid of that a little bit. There we go. Our initial velocity is 64 feet per second, and then we have times t. And our initial height, where it started from 5 feet up in the air. Okay, so now in order to find this axis of symmetry, we need to do negative b, so negative 64 over 2a, so 2 times negative 16, and that gets us negative 64 divided by, I suppose that's just negative 32, that gets us 2. And so what does that mean? Well, that means that this is going to be 2, and so if this axis is time, You know, after how long did it take? It took 2 seconds to get up to its maximum height. Okay, and then the second question, how far above the court level was it at that point? Okay, well, if you remember from a couple days ago what we do, how far above the court level, we're just going to take 2 and we're going to plug it in for t, and the y will tell us how high it was at this point. Okay, so y equals negative 16, and then 2 squared plus 64 times 2 plus 5. Okay, calculator work here. Negative 16 times 4 plus 64 times 2 plus 5. And it gets us 69 feet. So it reached a max height of 69 feet. Okay, and the third, what is the range of the function that models its height? So, I mean, its max height up here. Again, my graph's not accurate, but its max height was 69 feet after 2 seconds. And so what's our range? Our range is, it can't be, it has to be less than or equal to 69, because that was his max height. But then if you notice, our graph only goes down to 5, doesn't it? It never drops below 5. It starts at 5, it goes up, and then it stops at 35. And so we actually have to add a little piece of this, is that it also has to be greater than or equal to 5, because it's never going to drop below that. Okay? Now our last one here. I don't know if I'll have time for it, but we'll get going as much as we can. Alright, Daniel kicks a soccer ball up in the air. Initial upward velocity of 40 feet per second. The ball is 2 feet above the ground when it's kicked. How long will it take the ball to reach its maximum height? And then other questions. Alright, so we have our y equals negative 16 t squared plus vt plus c. Okay, we plug in what we know. It was 2 feet to start with. Okay, so we have plus 2. Initial upward velocity of 40 feet per second, so plus 40t. And then we still have our negative 16t squared. Okay, our first step is negative b, so negative 40 over 2a, so 2 times negative 16. And that would be negative 40 over negative 32, which is a decimal. That'd be like 1.25 seconds. Okay, 1.25 seconds is how long it will take to reach its max height. Okay, and how do we find how high above the ground will it be at that point? Well, we take that and we plug it back in for time. Okay, so we get y equals negative 16 times 1.25 squared plus 40 times 1.25 plus 2. And I trust you'll do this on your own. As far as figuring out what that answer is, it turns out to be 27 feet. Okay, so after 1.25 seconds, the ball is 27 feet above. And what's the range? Well, if you think about it, he kicks it from a height of 2. Oops, kicks it from a height of 2, and that's the start. Okay, and then it goes up, and then it goes all the way back down to the ground, doesn't it? But it can't really go below ground, and so our range would be, it goes from 0, it's greater than 0, but then it tops out at, what, 27 feet? And so it has to be less than 27 feet is what it tops out at. So it's between 0 and 27. All right, that's the section. Here's your homework.